So basically, this is like that sensor that I used. This is that sensor. This one, just I used this. It's like something so simple. Everything one can make it, or you can just buy it just like that. This is much better than this one, of course. Okay, but I just want to make this like so simple, so I'm not make it. This one is like quite similar to this one. This one is actually a bit like it has like this can change the depth. I'll just talk about it. Okay, so I will talk about the working principle of that sensor first of all. Then I'm going to do that second one. So this sensor, it is basic working principle is about changing its resistance. When the resistance changes, then it means what? You are conductor of this resistance changes, the current flowing flow will change. Resistance is high, then the current flow will be low. When the resistance is like low, the current flowing to that one will be high. So this is like basic principle, working principle of that one. So as you see, like it is this one. So you're just like planting like a soil. You have a plant over there. Like this is your plant here. You're just like putting over there. Okay. So the current will come from one side to another one. Okay. So when the soil is wet, it means that there's no ions. It means that there's no ions. More ions means like more conductivity. So it means when like the current, I will just come into that the working principle of that setting. I'm not talking about this one right now. Okay, don't worry about that. But I'm just like talking about this thing right now. So it's like this basic principle is that when the soil is wet, it means more ions, more conductivity. Because that soil works like as a resistance between these two probes. Okay? So when it's wet, more conductivity. When it's like dry, the conductivity will be less because the ions from the water that provides will be less. Okay. Then this one will give us, of course, like an output. We all know that the sensors, their output is always like electrical outputs. Okay, because you know, like it's a type of like transducer. Okay, so like this output will be connected to a circuit that you wish to control. So my circuit is this one. Okay, I will just talk about it in a minute. So this is my full circuit. I make like that picture. This is my circuit that is going to control that water pump, which is this one. This is like my water pump. Okay? And this is like my water pump. This is my circuit. I'll just talk about it. Just imagine these two ones are like these two trucks. Okay? Let's see like how this one works. Yes, this one. So like this is like my circuit. This switch, okay, this switch, we can consider it like as my two trucks that together connect them with that soil. Okay, just imagine that. So we have like basically like it's like my circuit. Okay, this is like that battery that I use. Then like I have 100 kilo ohm of my resistance. Then I have 156. Then I have 43. Okay, but in that one like I have 50. Okay. So basically this one, consider this one like is our water pump. Okay, and this guys are connected like just for like the signal like the water for that. So and what I use like here we have like NPN transistor and here we have like PNP another PN. How these transistors like are working with that circuit? They are working like as like a switch. And turn on and turn off that circuit. Okay, that water pump. So when that switch is off, it means that my soil is dry. So it means the resistance between these two is high. So no current is flowing for that area. When no current is flowing for that area, okay, just look like this one, okay. So when it is like open, it means no current is flowing for that. So basically this circuit is open. So when this circuit is open, like this, it will just make this transistor to be on. be a reverse bias. If it's a reverse bias, it will be off. Then because this collector is connected to that transistor, that's only I'm just saying that talking about like what do you call it? All you know is like how the transistor works, right? Anyway, this one will be off. If this one is off, so it means that this collector is connected to the bias of this one. So if this one is off, this one will be off. If this one is off, this one will be off automatically with it, right? So when this one is off, okay, the current will just flow through that circuit because this one will be forward biased. It will be open. So this motor will start working. It means my soil is dry. The resistance between these two crops is high. Resistance is high. It means that the water pump will lower and it will just water these plants. Okay? Then basically like this resistance will change like it will not just change like that. Just for the sake of like understanding can explain it that way. Otherwise like this resistance more it will change like gradually. Okay? But imagine right now the soil is all wet. When the soil is all wet, it means that there's no current flowing through that between two crops. The current will flow between these two crops. When the current flows between these two crops, look, what will happen? This transistor will be forward biased. Okay? When it's forward biased, it means it will be on. When it's on, its collector is connected to this PNP transistor, so this one will be on too. Okay? But look, this one is coming to here, to this transistor. It is base. Okay? This one will make this transistor to be reverse biased, so it means to be off. No current will flow from collector to collector to terminal. So this is like the basic principle of my circuit. It's something so simple. Anyone of you like can understand. It's like very simple. And we have like a very of course like a better version of this one, but I just like wanted to make it as simple as possible. Otherwise we can have it okay. Just like we have here. And nobody has like a question on that, right? Anyone has? How was it working? Okay, so this one like the working principle of this circuit. Okay, so the working principle of that. Okay, so like right now let's come to this application. It's good for what like it's used in what? It's like automatic irrigation in agriculture. So like it's like a human is going like opening the like pipes and like watering plants. They will do something similar to that circuit. So it will be automatic. Then like anyone like in home they can install this kind of circuits and in greenhouse maintenance too. And like in smart city irrigation and like in more other places too. But I'm just like briefly I'm talking about it. Then of course anything that you make it has its own advantage and its own disadvantage. And this one is like of course it will have its disadvantage but it's okay. So like disadvantage so it's conserves like for someone like me, like I'm from Iraq, okay, like we actually like someone studying the road. So this kind of service like process like it will like benefit us too much like this like to conserve like water. And it will reduce manual labor. It means like the people that will not do by hand. So something they will automatically so it will reduce the working by hand. It ensures optimal plant growth. Look, that's a very growing okay. Then we have like disadvantage. This circuit that I made, okay, that's the gas light into the ground. Okay. A sensor degrades, okay. The sensor, this one is going to make will get gas over time. Because we are just planting it in like soil. And this is like right at the end, it's like metal. And there's going to be like chemical reactions so that this process will over time it will get back. Okay. And also like for request like calibration for different soil types because this circuit it's not smart, it's just like automatic. and not smart language. And I will talk about that when I get to the modifications. So like here we have possible modification of master. So as you have noticed when the applications of that, like this one is not like a smart one. It means like cannot what we call it to read the noise of that soil so precisely. But instead of that, we have something else. This one. Okay, you can go and buy that one instead of this second piece. You can install this one on that sensor. Basically, this is called what? This Arduino like Uno, okay? Which makes this circuit efficient and automatic, and also to make it smart. Mine is somehow like a little bit dumb, okay? So it's good for what? Like reading soil moisture levels. It will read like soil moisture levels, maybe like the voice is not that much. Maybe it's too much. Okay, so based on that one, like maybe that one will to come like that amount that's needed to be involved in that soil. Okay. Then deciding then to what the best of the ground.
Please make it fast.
This is the last one. Just read it. Okay, so like we can use this one. Or like then we can use like solar power irrigation. It means we can use like solar panels from this battery. Okay. And we can use like internet connected like someone like this one can see our conversion from an board. Okay, it's like application. Or you can use like multiple like sensors for that. Sensors like just we're gonna be when we're going to like better data. Then we can use like a lot of soil which is from this more durable and like better in more efficient than this resistant one. And also you can use like temperature and humidity sensors. These ones like material like this dryness because of wind or also like because of water. Okay, it's very more efficient and collecting. And this is like our sensors. That's like everything. And that's really like it looks like it's something. It's working. Okay. Just imagine like there's like connection between this one and the motor will be.
Like how do you correlate the voltage read by the sensor to the moisture level in the soil?
The voltage like